As the question says, the friction coefficient between the table and the block shown in the figure is 0.2. Find the tensions in the two strings. So friends, let us assume that there is tension T1 in the first string and T2 in this string. So now let us mark the forces on the first block, in which we are having an mg force in the downward direction, a tension T1 in the upward direction, and if we assume that the system is accelerating to the left with an acceleration of a, then this block must be going downward with an acceleration of a. Framing the equation for this block, I can write it as mass into acceleration equals to mg minus T1. Putting the values, we get 15a equals to 15g minus T1, or T1 equals to 15g minus 15a. Let us mark it as equation number 1. Similarly, looking at the block 2, in which we are having an mg force in the downward direction, a T2 force in the upward direction, an upward acceleration of a, we can frame the equation for the second block as mass into acceleration equals to T2 minus mg. Putting the values of mass here, we get 5a equals to T2 minus 5g, or T2 equals to 5a plus 5g. And let us mark it as equation number 2. Proceeding ahead, if acceleration is to the left, then this block must be suffering a frictional force in the opposite direction, and hence for this third block, let us frame the equation. Since mg force is in the downward direction, a normal reaction in the upward direction, so I can write it as normal reaction equals to mg equals to 5g, and in the horizontal direction, mass into acceleration is T1 minus T2 minus friction. So I can write it as 5a equals to T1 minus T2 minus 0.2 into 5g. Let us mark it as equation number 3. Now friends, putting the value of T1 and T2 from equation number 1 and 2 into the equation number 3 reduces the equation to 5a equals to 15g minus 15a minus 5a minus 5g minus 0.2 into 5g, giving us the value of acceleration to be 3.6 meters per second square. Now, let us put this value of a in equation number 1 in order to get the tension 1, that comes out to be 150 minus 3.6 into 15, that is 96 newtons, and putting this value of a in equation number 2 to get the value of tension 2, that is 5 into 3.6 plus 15, which gives us the value of tension 2 to be 68 newtons. So these are the values of the tension forces that has been asked in the question, that is 96 newtons and 68 newtons.